This is the last non-human example. Oops, until the next one. This guy Gilbert Gottlieb points out something that's really quite striking only if you look at it closely, and then it's like, what in God's name is doing here if you don't look at it closely, which is bone structures of the bone anatomy of two goats. If you're into goats and bone anatomy, these things might look like they're from different organisms, one with a thin bone structure, one with a much, much heavier bone structure, but this comes from some goat born without forelimbs that adopted a form of locomotion similar to a kangaroo, but instead of breaking its little bone structures, it actually developed more bone structures. That is, in an extreme case of novel behavioral experience, the entire physical structure of the thing changes such that it's kangarooish as a function of the behavioral experience. Okay. Here's back to a psychology-relevant thing, unless you're into the psychology of goats. The implication here is that from epigenetics, there might be a way of understanding at the level of biology and the brain psychological experiences. So if you were with us for material on, for example, personality and social development, you know that there's a bunch of ideas and data suggesting that early life psychological experiences can have some long-term psychological effect. Although he overstated it, this was the core idea of the first super major theory in the history of psychology. Much of Freud's psychoanalytic theory was built on this, its developmental aspects, built on this notion of early life experiences having some effect that reverberates somehow, though Freud never fully convincingly worked out the how in the way that people see convincing now, but somehow has a long-term effect on the organism. Although this that I'll put up is not exactly what Freud said, it is similar in that there's a way now of understanding, but at a biological level, what happens as a function of early life experiences. The study that I'll put up shows not only that early life psychological experiences have some effect on the biology of the organism through epigenetics, but incredibly the effects may be reversible. It's a non-human research example. The reason it's a non-human research example isn't just the difficulty of running studies like this with humans, because it takes them years to develop, versus some little laboratory mammal that develops more quickly, but also because one wants to pull off a little trick that I suspect for any institutional review board would be seen as unethical in the case of humans. The trick is to assign offspring to parents. That is, you want to find out if a certain parenting style affects an organism. And you might find out, you might know from prior offspring that the parent has had that some parents are good parents and some parents are bad parents. So the devious mad scientist experiment would be to take some infant or group of them and assign them randomly to the good or bad parents and see how they turn out. Maybe it's unethical to do that even in the case of little laboratory rodents, but the researchers here assume that it was okay to do that with rodents and it's not with humans. So this work is done with laboratory animals who are randomly assigned after a litter is born to good versus bad parents. The work by a really remarkable research group, Ian Weaver, Moshe Ziff, and Michael Meany, who does a lot of this work at McGill University, is on the effect and then reversible effect of adult behaviors on offspring. So the idea here is that if you're a rodent, there are good and bad kinds of maternal care. It's pretty straightforward if you're a rodent. Good maternal care is the mother paying attention to and often licking and grooming the offspring. There's a whole lot of just physical interaction with the offspring that obviously seems like part of good parenting for any mammals. You don't just want to just toss some food into the crib and hope the kid grows up. The physical interaction with the offspring may contribute to these sort of attachment processes that, it might be, actually affect the biology of the organism. So what they do is to assign brand new infants to mothers who historically have either been good at licking and grooming the kids or have been, if they can find them, and they can, relatively neglectful mothers who are less good at doing the licking and grooming and taking care of the organism. They then track the physical development and behavioral characteristics of the infant, including measures of its exploratory behavior. Essentially, though, you can't give an anxiety self-report questionnaire to the rodent. You can get a measure of like exploration, heavy quotes here, self-confidence of the offspring as opposed to anxiety and inhibitedness through exploratory behavior. So you do this in a laboratory setting by putting the organism in some novel environment and tracking whether it sort of cowers in the corner for 15 minutes or explores the environment. And then the researchers believe that they understand not only the fact that genetic mechanisms influence behavior and that maternal behavior influences genetic mechanisms, but though we won't do these details here in this lecture, they also understand the biochemistry well enough that they believe they can reverse the behavioral effects in adulthood of bad parenting in childhood, which would be quite clever if you can do this for adults too. That is, they believe they can do something that switches back on the genes that were switched off as a result of the stressful environment of bad maternal care. And so here's a measure of exploratory behavior at age 90 days. This is why you can do the study without waiting 10 years as you would in the human case, because these rodents grow up fairly quickly. So the vertical axis is essentially whether you've got an anxious animal sitting around doing not much or exploring the environment. The terminology low LG ABN is licking, grooming. That's the LG. It's literally just behavior, licking, grooming in the first 10 days of life. What happens in the first part of this study is that if you just observe these organisms, the ones who, and we know it can't be genetic because they've been randomly assigned to the parenting, who experienced bad mothering behavior, low licking, grooming, grow up to be relatively inhibited, anxious, or animals in young adulthood. But then, so that's what, as it says in the slide. But then, that is just the no drug condition. The researchers can then administer a drug that affects gene expression in a way that switches on genes that had been switched off, and then not long after they do that, presumably now affecting the biochemistry of the brain and inhibitory signals that become less inhibitory, they're able to reverse the negative effects of bad parenting. And, not that you really want to do this for a living, they're also able to administer a different drug that reverses the positive effects of good parenting in adulthood. They're essentially able to switch the, quote, personality of the rodents from inhibited to outgoing, confident, exploratory, and to show that if they don't use these drugs to switch the things on and off, they get behavioral effects not of genetics, but of parental experience. But, and now this is what changes the Locke-Kant nature-nurture game entirely. What changes is that the behavioral effects are mediated by the genes. The nurturing is affecting the biological nature such that the organism is physically different if it experiences a different parental environment. And this is a large effect. It's not like there's one gene. They identify more than 900 genes that are stably regulated by maternal care. And then some of these are reversible by this drug injection. This study is a few years old since that's done. There's a whole bunch of studies like this. Even within just a few days of the time I'm doing this filming, there's studies that show the genes are affected by seasons of the year. People get sick or are more well and feel different at different times of the year. It's psychological, but not just, because it's also the case that the genetic mechanisms are varying as a function of environments that in many parts of the world vary by the seasons.